you are doing great so far with this playlist. In this video, we will talk about Swift properties. We have various kinds of properties in Swift. Total, we have 5. We will start with stored properties. We will take a look at lazy stored properties and computed properties. And the fourth type is the property observer. Fifth is the type properties. We will not just understand these properties, how it works with the help of examples, but we will encounter a lot of questions, the confusing questions that we generally have, and that we will do along the way, and not just along the way. In the end, especially, we will have widely confusing questions that people generally have. For example, what all properties I can use with structure, with classes, can I use it with enum, and what all properties goes in integration with each other. We will also understand when to use which property, and that is one of the most confusing question everybody has. So we're diving deep into this. So grab your Xcode. Now let's start with the very first one, that is the stored properties. So when you need to store a constant value or a variable value that belongs to each instance. For example, I will create a struct here and I will have variable name and a let constant h. Now these are the two uh, properties. One is variable and this is a let constant which will hold a constant value. This will be tied up with every instance that you will create. So if I create person and give it some value, now the moment you create this object, these values are tied up with every instance. If I'll create, I will name it person 1, I'll create person 2, name Bob. So when you need the kind of properties which will be tied up with every instance that you create, that is called a stored property, and that is all. Running them, person, let's run it, and that is it. That is all a stored property really means. Let's move on to the next one, which is the lazy stored property. So suppose we have a class which is having some expensive operation. I will create a class data loader. We'll create a variable data. It will have a series of string values. Now these values I'm assigning it. I am going to be making a function here, load data. Inside that, it will return a string. Okay. So it's going to return data 1 and this few string values. And I will assign this function here. Now what's happening here is the property data is going to have this value where it is making a call to this function, and then whatever the value is in the return, it will be having that value, which is array of these values. Now when it comes to lazy stored property, there is a lazy keyword. I will copy this here and paste it here for clarity. Let's mark stored property as well. So if you'll see, we saw a stored property. Now it's a lazy stored property. So it's a keyword that you use with stored property. Now let's understand what a lazy keyword really means. Suppose this is a property which is having a value. from the function. Now this operation is very simple. Suppose this operation is expensive. You are loading a file from a network, from a server, or it's an expensive operation, or it's basically taking some time. So I will simulate that using sleep. I will do it for 3 seconds. I will print first that data is being fetched, and it will take 3 seconds, or it may, in real world it may take more time, and then whatever the data comes, we will return that data. Right now I will just return this array of string, but I'm simulating that this method is taking some time, and this is an expensive operation. So let's do one thing. I will create here data loader object, and let's call it data loader. Now what happens is, when I create the object, what it does in general is it initializes all the properties of the class. So it will initialize this, but right now this is an expensive operation and it is going to take some time. I don't want this when I create the object. I don't want particularly this property to be initialized. So what I will do is mark it as lazy. And what it will do is, if there are any other properties in here, that it will initialize, and it will not initialize the lazy property. So what we're doing here is, we are handling this expensive operation until we use it for the very first time. In the sense, when I say data loader dot data, I'm using this property now, but if I don't use it, and this creation is initializing this property here, then it's a problem, because every time I will create the object data loader, it will initialize the property, and at every creation of every instance, it will actually take 3 seconds, and we are not even using it. So we want it to be lazy, in the sense it should be only initialized when we are using it for the very first time. So what happens is, this lazy keyword will not initialize it when I'm running or creating the data loader object. To see one step deeper into this, let's take a look at the init. So I will say init, and you will see this is the hidden init. I've not we can see that I've just unhide that, and we can see there is no parameter here at the moment. It means it is not initializing the lazy property. So when I run this, or when I write data loader parenthesis creating the object, it essentially runs this. If suppose I had a variable integer here, and now if I will check init, it only initializes this one. So when I'm creating the object, it is initializing all the properties, but not lazy. If I remove the lazy keyword and now check for the init, you'll see it is initializing data and x both. And that is exactly what we don't want. We want the data property to not get initialized every time I'm creating the data loader. So what I will do is mark it as lazy. And now if I will check init, I have to do it again. Now if you will see, x is the only property which is getting initialized. And now when I will access data loader dot data property, it will initialize the value. That will take 3 seconds. I will print it, and let's run it and check this out. it will take 3 seconds before it prints the value. Before that, I will print the value of x as well, data loader.x. And of course, here we have to give the value to x. I will just give it 10. I will comment this print and let's run it. So you saw 3 seconds it took to fetch the data. Data is being fetched. That was the first thing we are printing. Then it takes 3 seconds and then it returns us the data, and that's what we print. It did print the value of x, but it did print the value of data later. If you don't use this here, it won't initialize the data. Let's run it now. And you will see the object is being initialized. All the properties inside is being initialized, but not the lazy property because it takes time. It is using heavy computation. It is basically being used when you fetch data from server, and it's gonna take some time, and we don't need it during the initialization of the object, but rather when we actually use it. And that is all about lazy stored property. Let's see one more example. I will create here a structure. Now in this example, it's an expensive calculation. There is a function which takes some time. So I will introduce sleep for 2 seconds. So it's taking some time, taking 2 seconds to fetch the data from the server maybe, or some other operation. And we are assigning it to this property. We marked it as lazy so that when we create the object, the init that will run will not have the result in that parameter and will not initialize anything there. Let's undo this. And now we can run it. I will say expensive calculation. This is object creation. It is not initializing that property. Although if you have any other property which is not lazy property, but just a simple stored property, then that you will have to initialize during the initialization. And let's introduce that as well for clarity. Now, if I will create the object, it will, okay, I will have to write it again. Expensive calculation. Okay, let me do init, and now you will see it will only initialize x and it will only ask for x. So let's do expensive calculation and check now. So Xcode does something tricky on us. Just be confident on your own understanding always. Now you will see that we have to only give value to the x, and the object is created with initialization of x only. I will call it operation, and I can access operation dot x and print it. Let's comment this print. We don't have any other print operations above. Now here when we will initialize result, only then when we will use result, only then it will initialize it. So if I say operation dot result, that is exactly when it goes to this method and does the operation. Takes 2 seconds and then it will print it. I will add print for that. Let's run it. Okay, so let's understand one more thing, that is this should be variable and not let. Let's run it now, and it says 3, which is value of x, and then when we are using it, then only it goes to the result and performs the calculation. Takes 2 seconds. After that it prints 45. Let's run it again, taking 2 seconds, and now it's printing. And that is it. That is what a lazy keyword really does. We can use lazy keyword only with stored properties. So if you have any confusion or question there, just always remember that we have a stored property and we have a lazy stored property. Now let's jump to the next one, which is computed property. Now, when we have the value dependent on other properties, that's when we use computed property. Let's take a look at the example first. I will here create a structure rectangle. So suppose we have this structure rectangle and it has width and height and a variable area. Now we want to give some logic to it. So of course we can create a function like this and give it that function here. But what if we don't want to give that function and we want to use this property which is inside the structure for computation? Well, you need to make this property a computed property then. For that, I will copy this and delete this and open a curly bracket. And that's it. In here, we can give that logic. Now, computed properties provide us getter and setter. Getter are mandatory and setter are optional. You can give getter and not setter, that would work. And what getter setter really means, let's understand that. So get block and a set block. To this we call getter and to this we call setter. Now when you are reading this value area, you will get whatever inside is there in get block here, and when you are setting a value to area, it will run this block. So when I create rectangle object and I will initialize, let's give it 10, and I am accessing rectangle dot area. This is getting the value, so it will run the get block. All I need to do here is give the value. I can return some normal value, or here I can give my logic where I'm using the other properties, that is width and height. So I will paste that logic here, and that's it. That is what you will get. We can run this. I will print it here, Let's comment the previous print operations. And let's run it now. It gives me the value. Now let's understand set. Now before we understand set, let's understand why we have to have the computation property when we are using the other properties for the calculation of the value for property area. I will just go back and write it width multiplied with height. Now let's run it first and we will see an error. I will comment this print and this one as well. So what the error says is cannot use instance member width within property initializer. Property initializer runs before self is available. Now because this width and height, what happens when we create the object is there is an initializer which runs, and that is the first thing that runs. So it will initialize width, height and area, all three, and only then you can use these variables. So you cannot use before the init has been executed, and that is why we want to make this property computed property, because initializer actually initializes only stored properties. So if I undo this, if I will make it a computational property. I will have a get and a set block, and here I'm printing width into height, and we will see initializer now. Here you will see it is initializing only two values, width and height, and not area. So because initializer initializes only stored property, we can use this properties within another for the calculation of its value only when it is initialized. So what we need to do is make this property some other type of property so that it doesn't become part of initializer. And what we did is we made it a computational property, and that is why it is not part of initializer, and we can give the logic using this. So what happens is when we create the object, we are initializing these values. When the object is created, you are going to use the area variable only after object creation, and when we use it, it will compute this logic and will get you the value. And now if you will run it, it will not throw the error. So it's not throwing any error. Let's print also. I will uncomment this, and now we are accessing area and just printing it, and it gives us the value. So that is how computational property works. Let's understand how set will work with the help of an example. So here I will create a square. Now in this example, it's a structure square and it has a property area of type double, and I've given it as predefined value. Now there is a computational property or computed property of type double, and inside that we have get block and set block. Now we know get block is necessary, it's not optional. Set block is optional. But before we see what it means, let's understand what set is used for. We know that set is used to set the value, and generally we think that since the get is used to get the value of the variable side, The set probably used to set the value to the side. Well, it's a bit tricky. The problem is if you set a value here, as you can see right now, we are setting using that new value, doing multiplication and setting that value to area, not side. But what if I want to set value to side? Well, let's try it in here. In the rectangle example, we were using get to get the value. Now, if I say I will comment this, and if I say react dot area equals to some random value. So this value will come in new value global variable, and new value is what I'm keeping here so that it will set it to the area, right? Now imagine what you're going to do is after setting the value is you're going to use it. So you will access it. So when you say rect.area, what happens here is it runs the get block. What it is going to do is it is going to run the logic that is width into height using the other variables, right? So when you did set the value, this new value here, it is of no use actually, because anyway whenever you are going to set the value, after that you are going to access it, and on every axis the get block will execute actually, and it will have operation which is using the other properties, and then that value, the properties, the logic will run, and that final value will be set to area, and that is how you read it. So we don't use the set block to set to this area property, and similarly in case of this example, I created a square structure. Here we are using set to set some other property, but not the computation property or computed property. And that is what the confusion generally everybody has. And I hope it clears it. Now that we know that how set works, let's understand that get is necessary, but set is optional. What it means when we use it. Let's see one example here. Before that, let's print this. I will create square dot area. I will say side. So it will give me the side. Let's print it. I will comment this print here and this as well. Let's run it now. So it will say this should be variable. Since this rect is the object rectangle, it is going under change because this area will change, and we have to mark it as variable always. We cannot use let. Now this is something we will learn in the characteristics. We will see the characteristics of computed property. Well, I will mention it here as well, but let's run it first. And it gives us 0. If there was some value, say 4, it will give you 2. And that's it. I think my Xcode is slow, that's why it is taking some time to run, compile and run it. Now let's take a look at the characteristics. The first thing that we just saw is define using where, not let. So the class or structure using computational property must be creating the object of type variable, that is where and not let. And the second thing is must include a get block, because if there is a computational property, then you have to have something to give here if you are accessing this variable, and optionally a set block. If it's not necessary, we can keep it optional, and what it will make it is a read-only property. So let's see an example. I will copy this rectangle example, taking this structure. Now you must have noticed sometimes I'm creating structures, sometimes I'm creating class. Well, all of these properties that we are seeing today can be used with a structure and class both. And we use it in exactly the same manner. So there are no questions there. And let's see now that what optionally set block really means. So as we don't need this set block here, I will remove it. And now it is just a read-only property. When we talk about area, it is just a read-only property. And whenever you access, it will give you the value. And since there is one more thing, since we have only get block and not set block in the computational property body, we can remove this get keyword and open parenthesis and close parenthesis. So we can essentially remove the get block and leave it like this. And this is another form that we see somewhere used in when we see a production level code. So just understand that there is no get block here, but it's a get only computational property. And let's access it. I will name it a rectangle1, create the object here. Again, we cannot give it let, we have to give it where, because it is having a computational property, and we will call it rect1 dot area, and let's print it. I will comment the previous print. We don't have any before. Let's run it now. So it says width height in call. Okay, I did not initialize the values, so now let's run it, and it gives us 3.44.0, 3 into 4 12, and that is what it means, and that is all that we need to understand about computational property. Now we can move to the next one, which is property observer. Now when we want to observe a property getting changed, that is when we use property observer, and we use it with stored property or lazy stored property, which are first two. Let's take a look at it with the help of an example. I will copy this and bring it here. So now let's take a look at simple example of property observers. I will create a class here. So now this is a class step counter, which has a variable steps of type integer, and initially the value is just 0. Now this is a stored property. So as we understand, now this is what it means is we are observing the property when there is a value change. Now it is used with stored property and lazy stored property, and you might have a question, can we use it with computed property? The answer is no, absolutely not. So let's take a look at one example first. When there is a we have this stored property. Now if I want to observe the change that is going to happen in its value, I will open a parenthesis and write here will set block and did set block. So we have two blocks, will set and did set. So we have two blocks, will set and did set. These are the two blocks which observes the property value change, and in this which is going to work for steps stored property. In this we can write a logic. Now let's print something here. Now will set is a block that will run when just before the new value you are assigning to this variable. So we will say about to assign new value, and in did set, so this block runs when the assignment of the new value to the variable steps is finished. So we will say added new value. So now what I will do is create the object and access this step stored property. Let's print it. Now it prints 0, the value. Now let's make change into it so that any change will be monitored with this property observers, which is will set and did set. So I will say counter dot steps equals to 200. And before we print, let's comment this print here. Let's run it now. And we see it prints the step, and then it says about to assign value. And once it is done assigning, it says well added new value. Now if you want to see this value that you have just assigned, you can also capture it here. Give it an variable here. So let's say new steps, and it will capture it here. We can get it in here in the print, we can mention it. So I will say added about to assign new value, that is new steps. And here we can say once the value has been assigned, we can say once the value is assigned, we can say added new value, that is new. Okay, or we can rather say that added steps, that is the variable itself. It will have the new value because did set is getting is running after the value is assigned. So the new value which is there in the steps minus old value. Now old value is again just like new value we saw previously. It is also a global variable, and I will write here steps. So old value will have 0. Let me give it 10. So old value will have 10 and new value will be 200. and let's run it. So we see about to assign new value, that is 200. And after it is done assigning, it will run the dataset block, which says added 190 steps. So this step, which is the variable, has the new value, and old value, which is the global variable, will have the value 10, and the subtraction, the difference is what we are saying, that we have added 190 steps. And that is it. That is what property observers are. Remember, it can be used, I will keep a note here, can be used with one stored properties to lazy stored properties. And we saw the question that can I use property observers with computed property? The answer is no. And that is it. That is what a property observer is overall. So now when can we use it? When you are updating a progress bar, let's say when there is this step property is changing, and you can also log a change. If there is a change you want to log for some debugging purpose, that is also one use case of property observers. Now let's understand the fifth type of property, that is type properties. I will bring it here. Now when it comes to type property, this is something when we create a structure and we have a stored property, and we will use the static keyword in front of it. Let's see the example first. So I will create a structure. So I have created a structure configuration which has default timeout variable. If I mark it as static, now this property is of type property. Why? And what it really means is, because when we use the static keyword, this property is associated with the type itself, in the sense when we create the object like this and we call it config, we cannot access this property using the object. It is associated with the type itself, so we can use the type, that is configuration, to access it. So if I use the object and say try to access it, it won't be there. But if I say configuration dot, you will find it there. So this is the type of property which is associated with the type itself and not the instances that you will create like this. Now this type property can be used with structure and classes, but we can use it with enum as well. I'll mention it here. So we'll see the example. So this is structure example. Let's see an example for class and enum as well. But before that, let's take a look at the structure, one more example, which makes more sense or make it even more clear. I will write here another. I'll create circle. Now what I've done here is I created a structure circle, and we have two variables, pi and radius, and area as well. Now pi is something which is fixed. It won't change ever because the value of pi is fixed. I can mark it as static. And here in the area, when I'm calculating, the formula for creating or calculating the area of circle is pi r square, in the sense pi multiplied with radius twice. So I would say return. I will access using the type name, which is circle, and access the static property, and right here radius multiplied with radius, and that's it. There is one more use case. I will create circle object here, and X is the area property. Let's print it. I will comment the previous prints. We don't have any previous prints. Let's run it. And it gives us a sort of error. Okay, I have to initialize it with a radius. So let's say 4.0. Let's run it now. And it gives us 50, which is 3.4 multiplied with radius and again radius. Now let's understand one example for class. Now before we jump to class, let's take a small example for enum first. I will create an enum here, compass, and have the directions, that is east, west, north, south, and have one static property as well. So let's create it. I can access that static property with the type name compass and access total directions, and we can just print it. I will comment this print, and it gives us 4. I will comment the print function which is returning first 2 lines here. So when we are making the change, it is calling this to observer. I will comment this and let's run it again. And it gives us total direction 4, and that is how easy it is to use with enums. Now let's understand how we use the static property with class. Now here I will create an example class vehicle, and I will have a max speed variable inside that. Now this variable property would be a computational property, and it will have only get block, or we can say only read only property it will be. So let's create that. So I will make it down 120. And now let's use the static keyword. And now it's a static property. I can use vehicle type to access it like this. And that's it. That's how we use the type property with classes. Now let's get one step deeper into this and understand what if I want a subclass to override this static property. What I mean by that is, as we have not seen inheritance so far, so I will give you a brief first so that we understand what subclass really means first. So I will create a class here, sports car, and I want sports car to inherit all the properties and methods of the base class, which is vehicle. What I do, colon vehicle, and that is how we do the inheritance. Now I want to override that. So what I will do is override variable max speed, and I will return 400. Now for base class to override the property, it is must be not using static, because static keyword is there to make sure that no subclass can override this method, and this method is attached or associated with only the type itself. So how do we actually allow the subclass to override this property? Well, for that we use class keyword. And why we use the class keyword? So that this property is still a static property, and we can allow it to be overridden by the subclass, any of the subclass. If there are other classes which are also inheriting vehicle, they can also override it. And why we say the class keyword only? Because inheritance is not there in the other two types, that is enum and structure. That is why we use class, and it also means that only class can do overriding of this property. Now this override will work, and we can access it, the max speed, using the type. So I will say sports car dot max speed. Let's print it. I will comment the previous prints, which is this. Now before we run it, let's add here class keyword as well. So override class and then the variable name. Let's run it now. I will comment this. Well, anyways, it says 400. Again, you cannot use the static keyword to allow overriding in subclass. We have to use the class keyword so that only subclass can override this static property. And in the subclass, we have to use override class keyword together, and then the variable name with after the variable keyword. Now this is it. This is what all of the property types really mean. And now let's tackle some confusing questions that generally everybody has. But before that, let's have some key points to remember here. So the first is stored property are used to store constant and variables. Lazy properties are delay. So lazy property delay initialization until they are first used or first accessed. So this is just a one-liner to remember the use or the purpose of the kinds of properties. So next is computed properties, which when we are calculating the values dynamically, that means we are using the other properties. Property observers monitors the change in the property value, and you can react to the change in property value. That means if you want any code to be executed in the will set and did set block, for you can fire impressions, or log the events, or you can log the events and fire the analytics as well. There is a lot more application of that is when it comes to production level code. Now the last is type property shared across all instances of the type, because the type property is a static property associated with the type itself. So every instance that you will create will have that property in it. It's just that you can access it using the type itself, that is the class name, the enum name, the structure name, and that is it. Let's tackle the questions. So can I use all these types of properties with struct, class, and enum? All three? That's the question everybody has. Now, I'm pretty sure this answer will actually clear out all of your confusion. And that is it. Here, stored properties, lazy property, lazy stored property, I mean, and computed properties, property observers, type property. So when it comes to structure, you can use all of the property types. When it comes to class, again, you can use all of the property types. But when it comes to enum, you cannot use stored properties. Enums do not support stored properties. And since it does not support stored properties, you cannot add lazy keyword to that. And hence lazy stored property is also not supported. Computed property is yes, we'll see an example on this. I will share it. So in the previous video, we have seen this example in enum video. That is, we are creating the cases, and for every case, we were having this custom string convertible protocol confirmed. Or even if you don't do that, it is by default, the enum by default confirms to that protocol. And after that, you can have this variable description, for which you can give description to a systematic string to each case. So what we are doing here is, this is the property, and it is a computational property, and you can think of all the code in it at the moment is a get block code. All the code is in the get block. There is no set block here. So it's a computational property, and this is the example for computational property, computed property being used in enum. So yes, we can do that. And we talk about property observers. So it is not supported in enum. We have seen it in classes and structure. We can do that. And property observers are used only on stored and lazy stored properties, because if you have a property to observe, then only we can observe it, and we can observe it using will set and did set block. So I will mention that as well right here. And finally, the type property that we can use with all of them. I will mention here one stored property. So stored property, when it comes to enum, this is all about enum. I will write here a question. Can I use the properties with enum? So for stored, it's not supported. For lazy, it's not supported. Computational or computed property supported. Property observer not supported. Type property supported. And there is a little description to it that will help you understand why. If we take a look at stored property, enums cannot have stored property because each case is unique value without associated memory. For instance, specific storage. However, associated value unique to each case can act similar to a certain scenario. What do I mean by that is, you need an initializer to initialize that stored property, and enum do not have it. But same with the lazy, don't allow lazy initialization because they don't support stored property. Since there is no stored property supported by enum, there is no lazy stored property supported by enum. Computed, we just saw the example. Observers, enums cannot have stored properties. Yes, so they don't allow property observers either. Next is property observer not supported. Enums cannot have stored properties, so they do not support the observer for them. And type properties supported, we have seen the example for this as well. And that is it. That is all there is to understand about properties and all the types of properties. When should we use them is also I will put here. That is one more question we will tackle. When to use which property type? So it's a big question. So when to use stored properties? When you have the let constant or variable values to store in the class or structure, again not enum, and that will be shared across all the instances that you will create. Lazy stored properties values is expensive to compute. There is an expensive operation and you might not need the immediate usage of that particular variable. And once the object is initialized, way later you want to use this property, because this property takes some time. For example, the operation could be you are fetching the file from the network, or you are initializing a resource heavy object. Only then you must go for it. Computed property. Now when the other properties are dependent and you need to calculate dynamically, then we saw the width into height, that is the store property that we were using to calculate the area of the property area. That is when we used it. The next, property observer. When we have something to log or monitor if there is a value change, that's when you use it. We can use it to update progress bar when steps property example that we saw, exactly that. And you can use it for debugging purpose as well. And finally, the type properties. You need value or configuration across all your instances. So why not just attach that property with the type itself, so that it will go automatically with all the instances that you will create without even initializing it. So mark it as static, and that's all. I hope you have liked this video. That is all there is that you need to know about properties in Swift. Let's connect in the next one.